So a kite is a quadrilateral with two distinct pairs of congruent consecutive sides. So distinct means that not all four are congruent. Not all four, not all four sides are congruent, just two distinct pairs. So two pairs and then another two pairs, another different two pairs, okay, are congruent, consecutive sides. Okay, so like there's one pair right there, QR and RS, and then QP and PS are distinct from the original pair right there, QP and PS, and that creates a kite. Okay? All right, so I mean, we'll kind of like maybe run through this just a little bit here, but if we use a protractor to measure PTQ and QTR, and then want to hazard a guess about the angle measure we're going to end up with here, what is it going to be? What's that? 90 degrees, exactly right. Okay, so what do we expect then for the diagonals of a kite? What kind of angle do we expect the diagonals of a kite to make? So for this kite right here, okay, we can see that there's clearly a right angle for the diagonals there. So what do we think in general is going to be true? The diagonals will be what? Perpendicular, yeah. Okay, and then would also have us measure PQR and then PSR. Okay, how do you think these two angles, PQR and PSR, how do you think these two angles are going to relate? PQR, PSR, how do you think those two angles will relate? Just by kind of looking at it, what do you think your eyes tell you? They're going to be congruent. Yep. So, okay. And then how about, will the same be true about QPS and QRS? Will the same be true? Does it look like angle QPS and QRS? Does it look like they will be equal? No. Okay. So the measure of angle QPS will not equal the measure of angle QRS there. Okay. So the kite has one pair of opposite angles that are congruent, but another pair that is not. Another opposite pair that will not be equal. Okay? Again, we're not going about constructing a kite. We'll just continue on from there. Okay? And so here are the kite theorems that we've got on the next page, page 472. Okay? If a quadrilateral is a kite, so notice that a kite, is a kite a parallelogram? Is a kite a parallelogram? No, right? Are opposite sides congruent? No, in fact, they cannot be, right? One pair of opposite angles are congruent, but the other pair of opposite angles not congruent, okay? So this thing is not a parallelogram. It's kind of a separate branch of like the quadrilateral family tree, okay? It's like a cousin, all right? But it's not like a, a direct blood relative of, or it's blood, I guess it's blood because it's quadrilateral, but it's not, like a direct descendant of a parallelogram, right? Okay, it's not a parallelogram. If a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. So there, like in this case, it's angle Q and angle S, or PQR and PSR. If a quadrilateral is a kite, then one of the diagonals bisects. One of the diagonals bisects the pair of non-congruent angles. Okay? So the non-congruent angles, their diagonal bisects them. But if you look at this diagonal here, QS, does it look like QS bisects PQR or PSR? Okay, it does not. In fact, it doesn't, okay, in general there, okay? So PR, that diagonal for the two non-congruent angles, that diagonal bisects it. But here for the diagonal that does not bisect the angles, those two angles are congruent, okay? And then in a quadrilateral, if a quadrilateral is a kite, one diagonal bisects the other. Okay, so notice here, QS is bisected by PR. But is the reverse true? Is PR bisected by QS? No, very clearly not, right? PR is not cut in half here. It's like up here. Okay? So we can use all those properties there to help us find unknown measures. All right? So for example, in kite ABCD, we have the measure of angle BAE, BAE, is 32 degrees. Okay? Only in geometry could your BAE be an angle. And then BCE is 62 degrees. BCE, 62 degrees. I detected massive amounts of eye rolling there at that last joke. That's okay now. And we're going to find each measure, okay? We want to find the measure of angle CBE. CBE. That's this angle right here. Okay. Well, what kind of shape do we have here, BCE? It's a right triangle. So if we know that's 62 and that's 90 right here, right? We know the diagonals of a kite are perpendicular. How can we find this missing angle CBE? Jenny? Yep, or we could just subtract 62 from 90 because these are going to have to be complementary too. But either way, yep, that works. So 90 minus 62 equals 28 degrees. Okay? And you see right there, they do the same thing. Okay. What about the measure of angle ABE? What about that measure? Well, same thing, right? It's another right triangle. So you can just do 90 degrees minus 32 degrees, and that's going to be 58. Okay. So 58 degrees. Which means, what is the measure of angle ABC? What's the measure of angle ABC? What's the measure of angle ABC? 86, exactly right, okay? So the whole measure of angle ABC is 86 degrees, which means what other angle here is 86 degrees? ADC, right. ABC and ADC are congruent angles. So that means this angle right here will also be 86 degrees as well. Okay, ADC will be 86 degrees as well. Okay, which we just did the your turn there too. All right. So angle ABC, angle ADC, they're congruent. Angle BAD, that is being cut into two. So like these two angles right here will be congruent, and then also BCA and DCA will also be congruent as well. So we know DCA will also be 62 degrees here. And that means EAD will also be 32 degrees as well, just knowing your properties of the kite. Okay. And BE, this is really getting messy, but BE is the same as ED there. Okay? All right. So that's it. That's kites. We've got it. Next, we'll talk about trapezoids. Okay? A trapezoid is a quadrilateral with at least one pair of parallel sides. So, is a trapezoid a parallelogram? No. Is a parallelogram a trapezoid? Yes. It has at least one pair of parallel sides. Okay. So, excuse me. This is a bit of a quirk of mathematics. All right, not everyone in the world defines trapezoid this way. Some people define a trapezoid as exactly one pair of parallel sides. And so in that case, a parallelogram would not be a trapezoid. But in this book, for our purposes, we're going to define a trapezoid to be at least one pair of parallel sides. Okay? So, the parallel sides are called the bases of the trapezoid, regardless of the orientation of the shape. So here's a trapezoid, here's the base on the top and the bottom. Those are both bases. But here's another trapezoid. The parallel sides are here and here, so those are called the bases. So don't think because it's on the bottom, it's the base. Bottom does not mean base. Base for a trapezoid is the pair of parallel sides. Okay? The other two sides then are called the legs of the trapezoid. A trapezoid has two pairs of base angles. Okay, two pairs, right? So here's like a base angle here, a base angle here. Here's a base angle here and a base angle here, right? And then here, base angles there, base angles there. Okay, two pairs of them because they have two bases, right? An isosceles trapezoid, well, we know the word isosceles for a triangle means how many sides are congruent? 2. So then for an isosceles trapezoid, we would expect the same, 2 congruent sides. And it's the 2 legs then that are congruent in an isosceles trapezoid. Okay? I think there's an error here in this diagram. Right? What's the marking that's wrong here? So yeah, Jake? Yeah, it's saying these 2 sides are congruent, which, I mean, I guess if they're saying it's not drawn to scale, they could do that, but I think they mean to put arrows there to show that they are in fact parallel, because that would make them the base sides, sides of the trapezoid. Okay, so let's continue on here. Okay. We're not going to worry about the proof. We're just going to look at the properties here. Okay, so 3 isosceles trapezoid theorems. Now before actually, let me go back here real quick. Okay, we don't really give any properties for trapezoid. There is maybe one property we could say here. How are these 2 base angles here going to be related? Well, we have parallel lines. Whoops, I think I'm going the wrong direction. So these 2 base angles will not be related, but these 2 will be. There we go. Parallel lines crossed by a transversal. How must these 2 angles be related? They're going to be what? Supplementary, right? And parallel lines crossed by this transversal, these 2 angles must also be supplementary as well. So I'm going to number these. 1, 2, 3, 4. So angle 1 and angle 2, or angle 3 and angle 4 are supplementary. I'll just add that in. Okay. I guess they don't say it because, oops, I'm sorry, it's like a little top right there. I guess they don't say it because it's something we maybe know from parallel lines. But I'll go ahead and say it there too. So 1 and 2, 3 and 4, those are supplementary. Same thing's going to be true in the isosceles trapezoid, right? These will be supplementary, these will be supplementary as well. All right, so let's continue on. If a quadrilateral is an isosceles trapezoid, then each pair of base angles are congruent. So for an isosceles trapezoid, base angles are congruent, which you can kind of see that here, right? Certainly looks like that's congruent to that, and that's congruent to that right there. Right? Makes sense. If a trapezoid has 1 pair of congruent base angles, then the trapezoid is isosceles. So the reverse is true too. Okay? If you have 1 pair of congruent base angles in a trapezoid, the trapezoid is isosceles. And then finally, a trapezoid is isosceles if and only if its diagonals are congruent. Okay? If and only if its diagonals are congruent. So if you see congruent diagonals in a quadrilateral, then if you see congruent diagonals in a trapezoid, then the trapezoid is isosceles. Okay, and then if you see a trapezoid that's isosceles, you know its diagonals are congruent then. Okay, so keep an eye out for that too. And again, you can kind of see it, right? If you were to like draw the diagonals, you see like, yeah, that looks about equal to that. Okay, whereas here for this trapezoid, you can see the diagonals definitely do not look equal. Dang, this trapezoid kind of looks like a kite. Well, it's not quite a kite, I guess. Can't be. All right. So again, we won't worry about the proof for that yet. Okay? And then I think, let's see, the your turn here is also a proof. We won't worry about that one. But let's go down to explain 3 to use the properties of isosceles trapezoids. Okay? So a railroad bridge has side sections that show isosceles trapezoids. So you can see there's the railroad bridge right there, and there's the isosceles trapezoid right here. The figure ABCD represents one of these sections. AC is 13.2 meters. B to E is 8.4 meters. So this section right here, 8.4. The full length here, 13.2. So how can we find the length of DE? Well, what do you know about the diagonals in an isosceles trapezoid? They must be what? Congruent. So 13.2 is the full length, and that's equal to 8.4 plus DE, the unknown length there. And so we just get whatever 13.2 minus 8.4 is. So 4.8 meters. Make sure I did that right there. My mental. Oh, it's in the book. Yeah, 4.8. My mental math and other thinking is off, I guess, a little bit today, but there it is. Okay. Let's try that one. All right, letter B here. Find the value of x so that trapezoid EFGH is isosceles. So if we're gonna say this shape is isosceles, this trapezoid, it's already a trapezoid, right? Opposite side, one pair of parallel sides. What must be true about angle F and angle E here? They're gonna have to be what? Equal. So we'll just set them equal. 3x squared minus 4 equals 2x squared plus 21. Okay, and then we'll solve. Subtract 2x squared from both sides, you get x squared. Add the 4 over, you get 25. So x is 5. Okay. Technically, we should put plus or minus 5, but again, actually, you know what? Never mind. We could put x equals negative 5 here. It would work because you're going to square it. So x could be 5 or negative 5 in this scenario because it would still work in the context of the problem. You're going to square them anyway. Okay. All right. So why don't you guys go ahead and try 8 and 9. 8 and 9 there. Give those two a try real quick. 8 and 9. See what you can come up with there. 8 and 9. Okay. So hopefully you got 103 and 4 there. 103 and 4. Questions on any of that? Okay, one more thing I want to talk about, and then we'll cut you loose here on the assignment. Okay, and that is the trapezoid mid-segment theorem. Okay, the mid-segment of a trapezoid, well, again, you can kind of see it, what it is right in the word. It's a mid, so halfway segment of a trapezoid, is the segment whose endpoints are the midpoints of the legs. So you have a trapezoid right here. Here's your two parallel sides. Okay, that mid-segment, it connects the midpoint of this leg with the midpoint of this leg right here. Okay. Okay. And there's a relationship that shows up with that then too. Okay. In the theorem here, okay, the mid-segment of a trapezoid is parallel to each base. And it's like kind of like, yeah, we can see that. Right, you can see that's going to be parallel there. So maybe I'll put that little... Okay? And its length is 1/2 the sum of the lengths of the bases. Okay, so in other words, xy is half of BC plus AD. Or you can think of the average. BC plus AD divided by 2 gives you the mid-segment length. Okay? Add up BC and AD, divide by 2, find the average of those lengths, you get xy as your length there. Okay? So, in trapezoid EFGH, find xy. All right, well, there are two bases, 10.3 and 12.5, so we'll add them up. Okay, and then we'll multiply by 1/2. And we end up with what the book says, 11.4 right down there. Okay, so you add the two up, divide by 2 or multiply by 1/2, you get 11.4. Okay, easy peasy. Letter B is a little bit different though. We're trying to find JM. We have the mid-segment length here. Okay, we have the mid-segment length. So how would we set up our relationship here for letter B? It's going to be 1/2. Let's call JM x. Let's call that length x. So it'll be 1/2 what plus what? X plus 8.3 equals what? The mid-segment 9.8. Okay, there's JM right there. There's JM right there. So how do we solve this equation here? What should we do to both sides first? Or what can we do first, I guess? We don't have to do, there's kind of two different ways I can see about going about this. So the first thing we do, we could multiply both sides by 2 to cancel out that 1/2. Alternatively, if someone was thinking, Mr. Wade, we could distribute the 1/2 to each of these terms. You could do that too. Okay? Either way, you're going to end up with the same answer. Let's multiply 2 on both sides first. So we get x plus 8.3 equals, let's see here, it's going to be 19.6, I think. Yes. Let's subtract 8.3 from both sides. So you get 11.3. Okay. We can check our work too. 11.3 plus 8.3 divided by 2 gives us that 9.8 mid-segment there. So aha, it worked. Okay. Questions on any of that? I kind of sped through that because I wanted to get you guys time to get started on the assignment. Okay. Yeah. Well, so there's kind of like on page 478, there is like the last Venn diagram with everything on it that we've talked about, right? We've got the square in the center. We've got the rhombus here. We've got the rectangle here. We've got the parallelogram here. But now notice the parallelogram oval is contained within the trapezoid oval. Kites are in their own little oval to themselves. They're not a trapezoid, they're not a parallelogram, they're not a rectangle or rhombus, and they're all, though, contained within that quadrilateral space. Okay, so there's like a little Venn diagram to show how they all kind of relate to each other. Your homework that I'd like to get started on now. Okay. Page 479, numbers 1 through 4. Uh, 12, 13. 15 and 18. Okay, I think that's all. Remember, this material will not be on tomorrow's quiz. If you are concerned about tomorrow's quiz, or you just want to get a little more practice, you go back to the homework we did, last night, the one we just checked. If you want to try the evens there, I'll be happy to come out and help you with that. Otherwise, let's work on this or your 10 marks assignment. There is a new 10 marks assignment. There is a new 10 marks assignment as well. Okay, you can get started on that. We don't quite have everything covered yet, but I can help you with that too if you'd like to do that. Okay. Question.
I thought I showed you this, but maybe I didn't when I came back. But this is Z and half.
Okay. Okay. Let me pull that up here real quick. Check. Yeah.